And I do have a couple of things that I just want to mention to you because our first week of Pogo we just finished, right? And I will have to say that you guys, this section was a lot better than the first section as far as filling out the surveys. But there are still some of you, I mean, a good handful of you that didn't do it. So let me be clear right now, okay? And it's recorded, so you can come and watch it later if you want to. Let me be clear. If you do not do the surveys at the end of the week, like I tell you to, you are going to get a big fat 0 on the entire Pogo. Okay, so does everyone understand that? Is that a yes? I only see
Yes.
and Kennedy because I see their heads. But
Yes.
okay, I mean, that has to be crystal clear. Okay, and like I said, you guys did a lot better than the first section, but there's still a good handful of you that didn't do anything. So why would you want to get a 0 on something that's worth 10 points? Each Pogo is worth 10 points. So that's a lot of points when you start counting them up, right? These little eye clickers are only worth 1 point here, 1 point there. But if you miss a whole freaking Pogo just because you didn't do the stupid survey, that's silly. So make sure you are doing them by Friday at 7 o'clock or whenever it is I tell you. I think it's 7 or 5 or whatever, but do it by Friday. Because Bree needs that information. She grades it in the weekend, and if she doesn't see it, you get a 0. And I did tell her this week, because she told me, she's like, hey, there's a bunch of people that haven't done these surveys. Do you want me to just give them a 0? And I said, no, I'm not going to be super mean. It's the first week. Let's be lenient. Let's give them a warning. But that's it. Leniency is done. So you don't do it, too bad, so sad. And then another thing, since we're on that topic, I know I sound like a broken record. I know. But there's so many of you in this class. Actually, your section is the worst for this topic. There's so many of you in this class that don't do the quick tutorials. It blows my mind. Like, I don't get it, right? Like, I don't get it. There are points that you could be getting. And right now, up to all the quick tutorials that we've done, I think that's a total of like 20 points that you could have already had. Okay, fine. Maybe you didn't get all of them right, but you still would have more points than what you'd have right now. So the fact that you don't do the quick tutorials before we come to class, like I tell you to, and I remind you, and I tell you again and again and again, it just absolutely is ridiculous. It's absolutely ridiculous because you are not concerned about your grade, apparently. So I know I've said that before, and I will try not to say it again, but every time I grade them, it's like I see all these blanks, and I'm like, what is the matter? They take 10 minutes. Like, why would you not do it? So I just want to point that out. You know, you guys have to do everything I give you because you will not pass. I'm dead serious. You don't look at them like bonus points. These eye clickers, don't look at them like bonus points. Look at them like points, because when that test comes, you're going to be really, really shocked. And you're gonna be like, oh, damn, I should have done this. And then it's too late. So just FYI, all right? Today, we're gonna start talking about chemistry. Yay, I'm so excited to talk about chemistry. I love math, but I really, really love chemistry. So we're not gonna do a Pogo today. We're gonna actually start it on Wednesday. I just wanna talk about it and basically on the stuff that you're gonna do on Wednesday, so you're not lost. There's no excuse. All right. So the quick tutorial was on the add-on. Let me share screen again. Where are you guys? Share. Does anybody have any questions before we start or no? Hello?
I have a question.
Yes, go ahead.
So with the eye clicker, I'm on the free trial, but each time I tried to pay, it wouldn't let me pay.
Okay. So that's something you got to figure out. Maybe contact the company or something, but they should. That's the silliest thing I've ever heard, right? Like, if your company doesn't want to take your money,
right?
They should want your money. So maybe it's just something with your phone or, something silly like that, but you figure it out. Cause I think that trial ends in like a week, right? Cause it's 2 weeks, but
right.
Probably ending soon. Yeah, figure that out. And if it's still not working and you're getting frustrated, ask me offline, like email me and let me know. Maybe I can, but I don't know anybody at iClicker. It's not like I know them. I would
Right.
call the same way that you would call.
Okay.
But I think I remember having a student that had the same problem, and it was because, and you don't have to answer, but her particular situation was she was using her parents' credit card. And I think iClicker, I don't know, like it didn't allow that because the names were different. So maybe if that's your situation, maybe call them and let them know, because she got it fixed. But I don't know, just try to see if you can call them and contact them and see if they can help you. Hopefully, I know that didn't help, but hopefully that gives you a direction. Okay, so any other questions?
I have a question.
What's up?
So today for one of my classes, Zoom wasn't working. So if Zoom stops working, are we gonna move to Blackboard, or are you gonna?
What do you mean Zoom? Like Zoom is not gonna stop working for me.
No, it's
No,
like
it was
because
this morning.
everybody's.
All the classes in the morning were off, but then they fixed it later on.
I have a class in the morning, and it worked. At what time was your class?
Mine was 9:30.
And yours, Christian? I think that was who talked, right?
No, I was just saying because my parents got an email saying that most of the classes this morning, the Zoom meetings weren't working.
So that is like SOS. I don't know, but I have my own Zoom account. So I mean, I'm not really concerned about what happens with TU because you're invited to my Zoom account. So hopefully that won't ever happen to us. But yeah, no, I'll probably be like a chicken without its head cut off, running around crazy. But I will let you know. And no, we probably will not meet on Blackboard. I'll probably just be like, we're gonna cancel class because I can't deal with this until I figure it out. But that's never happened, and I hope that you verbalizing it into existence doesn't now jinx us.
Oh.
And now it happens. But I'm sorry that happened to you, but no, we yeah, let's not even talk about that. I don't want to talk about that.
I'm sorry.
All right, any other questions?
I was just gonna say it was a problem with Zoom, like the company, not with Tuskegee. It was like a nationwide thing this morning.
Okay, yeah, well, that would be disastrous. But thankfully I don't have early classes, like early classes, because I'm not an early riser. I'm a late person, so I don't have early classes. So hopefully they'll get whatever happens in the morning and they'll be fixed by the time we have class. Okay, so the atom, that's basically what we were talking about, or what you guys had to, chapter 2 starts on the atom. So the structure of the atom, what an ion is, isotope, all this good stuff, but basically the beginning of learning the atom. So can anybody tell me what are the 3 main parts of the atom?
Protons, neutrons, and electrons.
That's right. Super easy, right? Even if like you watch, even let's say you don't even read chemistry, which you should, but let's say you watch cartoons. I think there's a cartoon named Jimmy Neutron, which this morning they told me that that's still around, right? Like Jimmy Neutron. Does anybody watch that?
All the time.
Okay, good. So that should help you, because at least you know what the model or what an atom sort of looks like from Jimmy Neutron, and you kind of know protons, electrons, and neutrons. So it's really, really simple. There's only 3 things. I mean, there's more things, but for this class, all you guys really need to know are those 3 things. And why do I have the periodic table up here on the screen is because you'll notice that from now on, I'm going to keep saying, if you know how to read the periodic table, and when I say read, I don't mean, oh yeah, I can read there's an H there and then there's an HE there. No, that's not what I mean. I mean, understand how the periodic table is organized and realize that hydrogen is in this column, but that doesn't mean, it doesn't just mean that. It means so much more. You understanding the organization and being able to actually fundamentally read and understand why everything is where it is in the periodic table will help you until last day of class. Okay, so the periodic table is really, really important. But we're not going to talk about organization yet. We're going to talk about atoms. What better way than to show the periodic table? So protons, electrons, and neutrons. Okay, so when you see a periodic table, you notice that there's a bunch, let's concentrate on hydrogen, which is the first box, yeah? There's a bunch of stuff in the box, right? There's a symbol, which obviously tells you who it is. And then there's a number on the top, right? So this little one here. And then you notice if you look at helium on the right, a number on the top, that's number 2. And if you keep going, it goes in order, which is wonderful, easy enough for us to remember. But can anybody tell me what that number on the top is? What does that say? What does that number 1 mean?
It represents the order and the I mean no, it represents the number.
You cut off. It represents the
Number of protons.
Correct. The number of protons. So right there, you can tell that the periodic table goes in order of what?
Protons.
That's right. It goes in order of atomic number. So another word for protons, right? So the atomic number of hydrogen would be 1. Why? Because hydrogen has 1 proton. And another piece of information that you kind of is subliminal there is, first of all, every single atom that you look on the periodic table is neutral. Neutral, has no charge. Okay, so if you know that hydrogen has 1 proton, and proton is positive, right? So protons are positive, electrons are negative, and neutrons are neutral. That's why they have that name. So if you know that hydrogen has 1 proton, then how many electrons must hydrogen have?
1.
Easy enough, right? So if I say this guy here, lead, number 82, yeah? Number 82 right here. How many protons does lead have?
82.
Easy. How many electrons does lead have then?
82.
So freaking simple. This is like a bunch of dumb questions what I'm asking. So that's 2 pieces of information that you can get just by looking at the periodic table. There's another piece of information. I mean, and that's only 3, but there's a lot more. But anyway, you can also tell how many neutrons something has from looking at the periodic table. For this one, I want to go to helium, right? So helium's number 2. Helium has how many protons? Quick.
2.
How many electrons?
2.
Okay. How many neutrons? Does anybody know how to tell that?
Isn't it also 2 because atoms usually have the same number of protons they do neutrons?
That is incorrect, but your answer is correct. Your answer is correct. It is 2. Helium does have, this particular helium does have 2 neutrons. But the reason is because I looked at this number here. So we've talked about everything. We've talked about the number at the top, the symbol, but there's one other number, the number at the bottom. That number tells you how much it weighs, right? Like how much the actual atom weighs. So helium weighs 4. And if you know that protons, helium has 2 protons, then 4 minus what will give you how many neutrons? 4 minus 2 protons will give you how many neutrons it has. Does that make sense?
Yes.
Okay. Let's just before, because there's a lot of other stuff I want to say, but just make sure that everyone understands. For example, let's look at phosphorus. Phosphorus is right here. Yeah, right there. How many protons does phosphorus have?
15.
How many electrons?
15.
How many neutrons does phosphorus have?
It's either 15 or somewhere between 15 and 16.
Okay, so that's the reason I picked it. You're absolutely right, but the reason I picked it is because you can't have like half a neutron, right? It's only either, they're integers. So we would round up and say this is phosphorus 31 because it's 30.97, right? So it's phosphorus 31. So 31 minus 15 would be 16. So it's got 16 neutrons, okay? So that is how you tell how many neutrons something has. Pretty simple, right? Now, does anybody have any questions before I keep going?
Could you possibly zoom in on the periodic table? It's kind of hard to see the atomic mass.
Yeah, I will when I will, because I want to write too. But yeah, I will whenever I ask you for another number. But do you understand, or is everything else good?
Yes.
Okay, cool. So I actually, let me see if there's something else that I want to mention before we move on. Okay, so we've got, actually, yes, I do want to show you something. Before I show you that, let's go back to here. So you guys told me there's 3 things in an atom, right? There's protons, electrons, and neutrons. I just said, and let me zoom in. I just asked you about helium, right? And you guys said, oh no, helium has 2 protons and it also has 2 electrons and it weighs 4. If it weighs 4, then 4 minus 2 protons gives me 2 neutrons. Easy. Okay, but wait a minute. So how much, I mean, everything weighs something, right? You weigh something, I weigh something, right? So why are electrons not incorporated into the mass of the atom?
Because they're extremely light relative to the protons.
That's exactly right. So really, you should say no, Tournay, you're wrong. They actually are accounted for, but they're so insignificant. I think it's like 1 electron is like 18, it would take like 1,000 or 2,000 protons to basically, what's the opposite? It's 1/2,000th of a proton. And there you go. That's what it is. 1 electron is 1/2,000th of a proton. So it's like tiny, 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 tiny compared to already a tiny proton, right? So it's so insignificant to the actual mass that it does not change the mass of the atom. So it's in there. It's just not really. It's really not that big. So you don't have, you can say now, oh, it's okay, everything's accounted for there. It's just that protons and neutrons almost weigh the same. And that's actually what I want to show you here. This slide here, right? So, and this kind of tells you what I was trying to say, is that protons and neutrons, which live in the nucleus, right? They live in the center. So that tells you that most of the mass of the electron, most of the mass of the atom is in the center, in the nucleus. And who lives there? The protons and the neutrons. And they pretty much weigh the same, around 2,000, right? But then you look at an electron and it's like 1 over 2,000. So it's like really, really, really tiny. Okay, so with that said, this is actually a picture of your POGL that you're gonna start on Wednesday. So this poll, everyone don't get, okay, so when you look at these things, you have to realize that people do symbols or write symbols differently. So for example, this number up here, you're used to, if you look at the periodic table that we were just at, the number up here tells you the 2 tells you the atomic number, right? The number of protons. But that's not the same thing here. Here, you can tell that it's not the number of protons because it's changing. What is one big thing about the atomic number or about protons, about an atom? Do they change? Do protons change? So for example, yeah, they don't, right? So like, it's sort of like in the quick tutorial I said, it's like your social security number. You have a social security, I do, I have one. If you change it by a digit, it's not me anymore, right? So that's who identifies, that's how you know who it is, what atom it is, because of the number of protons. That's why everything's in order, 1, 2, 3, 4, 5, in order of protons. So my point being that when you see an activity like this on Wednesday, don't get confused, because you can tell that the number up here is obviously not the number of protons because it's changing. It can't change. So what do you think that number up there actually is representing?
Maybe the number of electrons.
The number of electrons is not the answer, but that's a good guess. The way that you denote the changes of electrons are on the right-hand side of the symbol, but we're not there yet. So what it obviously does denote is the mass. So remember, hydrogen, let's go back to here. Hydrogen is the first one. It's very common, it's very, very special, but hydrogen has 1 proton and it weighs 1.01 AMU, atomic mass units, okay? So if you look at this box here, this is sort of like a make-believe periodic table. It's showing you 3 different hydrogens, 1, 2, 3. The first one has 1 at the top, but look at the mass, right? The second one has a 2 at the top, but look at the mass. So what do you think that number means at the top for this activity?
The isotope.
Okay, yes, the isotope, but more simply, it's the mass, right? It's telling you the mass of the atom. So my point is there's different activities that show different symbols, so do not get confused. You can figure it out because the periodic table has the number on the top of the atom, it's the atomic number here. It's not the atomic number here. It's displaying the mass. Okay, the most of the mass of the atom comes from the center. What's in the center? Protons and neutrons, right? Okay, so we know, and I said before, that every atom in the periodic table is neutral. So this box right here, the first box, says, I'm going to ask you, how many protons does hydrogen have in that first box?
1.
Correct. How many electrons does that hydrogen have in the first box?
1.
Okay. How many neutrons does the first hydrogen have?
1.
That's impossible.
None.
Okay, for whoever said 1, sorry, because I don't have your names up, but whoever said 1, who was that?
That was me.
Cherish?
Sorry.
Okay. Okay, so it can't be 1, Cherish, because this mass tells you the mass of the atom. Where does most of the mass come from? The inside, right? The nucleus. And what's in the nucleus? A proton and a neutron. So if you know, and they both more or less weigh the same. So if you know that the mass is 1, but hydrogen must have 1 proton, then how many neutrons does that thing have?
None.
It must have none. And that's actually one of the anomalies of hydrogen. I mean, it's got many anomalies, but one of the special things of hydrogen, it's the only atom in the entire periodic table that has an isotope. We'll talk about that in a second, but that has a version of the atom that has no neutrons. How do you know? Because you know that it has 1 proton, because the atomic number, and look what it weighs. It weighs 1. So therefore, it has to have no neutrons in one version of it. Okay, but now let's look at the second box. Okay, so how many, again, the whole class, how many protons does hydrogen have? It's a dumb question.
1.
Correct. How many electrons does it have?
1.
Okay, so how many neutrons does this guy have?
In the middle, it has 1.
And why do you say that?
Because when we look at the mass, it's 2. And we know that hydrogen has 1 proton, and we already discussed that if it has 1 proton and no neutron, the mass is 1. So if it's 2, that means it has to have a neutron.
Exactly. 2 minus 1 proton is 1 neutron. Easy, right? Okay, so before we go to the third box, let's go back to here, right? So now you look at, go back to helium, okay? So helium has 2 protons, which means it has 2 electrons, which means, Kennedy, like you said, it has how many neutrons?
2.
2, because 4 minus 2 gives you 2 neutrons. Do you guys understand that?
I do.
Yes.
Yes.
Okay, so let's try another one then. If you understand that you guys should be able to tell me, let's look at nitrogen. Where's nitrogen? How many?
Number 7.
Number 7, right, exactly, right there. So how many protons does nitrogen have?
7.
7.
Electrons?
7.
Neutrons?
7.
7.
Okay, well that was easy. How about this one then? Phosphorus, right under it. How many protons?
15.
Electrons?
15.
How many neutrons?
16.
16.
Okay, 31 minus 15 equals 16. So therefore, look at all the information you can get just by looking, and that's not even a quarter of the information you can get, but that for today, look at all the information you can get just by looking at the periodic table. Okay, let's go back to this. when you have a
Yes.
different number of neutrons in the atom, right? Because there's different versions, right? This is version 1, this box, and then this box here is version 2. It's the same atom, but it's a different version of it. So when you have different number of neutrons in the same atom, they're called isotopes. That's what the name is. So from now on, when I say an isotope, don't be confused, because we've already talked about it. Okay, so you have hydrogen 1, okay, and then you have hydrogen 2. Why? Okay, so obviously I'm adding numbers, right? But hydrogen 1 refers to hydrogen with mass of 1. Hydrogen 2 refers to hydrogen with the mass of 2. And there is actually a third isotope. It's called tritium. It's called hydrogen 3, which weighs 3. Okay, so when I say nitrogen 15, okay, nitrogen 15, remember that, and we go back to nitrogen, see, it's not this nitrogen, it's a different version of this nitrogen. Okay, so how many neutrons would nitrogen 15 have?
8. 8.
Okay, is that the only person that knows their math? 15 minus 7 equals 8. So that would be a different isotope. That would be an isotope of nitrogen, okay? So that's how you know what an isotope is. It's just a different version, a different number of neutrons from the guy that is on the periodic table. So that brings us to a good question. Maybe you guys are thinking, well, why the hell did nitrogen 14 get to be so lucky? Why did he get to be on the periodic table and nitrogen 15 didn't get to be on it? Well, it has to do with availability, or not availability, that's not the right word. It has to do with the amount of percentage that isotope is present, right, in our natural world. So for example, carbon also has a couple of different isotopes. Do you need to know the different isotopes? No, you do not need to memorize them, but you need to know if I tell you, oh, okay, we have carbon 12, you know what that means. And if I say carbon 13, you also know what that means. So there's 2 carbon isotopes, there's more than that, but these are the stable, naturally occurring isotopes of carbon. So you have carbon 12 and you have carbon 13. It ends up being that carbon 12, when you actually test it, is around 99% of the time you're going to find a carbon 12. That means that only 1% of the time you're going to find a carbon 13. So since carbon 12 is more dominant, right, in our natural world, it gets to be the dude that gets on the periodic table. All right. So, and we're going to go back to these averages and percentages later. But do you understand that? Everyone get that?
Yes.
Okay.
Yes.
So you do not have to know the different isotopes. That's not important, but you do need to know and be able to recognize that this neon here is the most stable isotope because it's the dude that's on the periodic table. So if I give you something different, and that's what I was talking about in the quick tutorial, if I give you something different, you'll be able to tell me how many protons, neutrons, and electrons that thing has. Okay, let's go back to the POGO. What about this third box? Oh my goodness, what the hell? There we go. This third box here. Is this box displaying an isotope of hydrogen?
Yes.
You know you're gonna have to justify. If you say yes, you're gonna have to justify it. If you say no, you're also gonna have to justify it. So whoever said yes, tell me why you think it's an isotope.
Because it doesn't have any neutrons.
Okay. So tell me the definition in your own words of what an isotope is. We just said it.
An element that doesn't have any neutrons.
That's not what the definition is. I did not say that. That never came out of my mouth, Kennedy. Never. That never came out of my mouth. I never said an isotope is something with no neutrons. Never said that. So
can I go?
Yeah, go ahead. Help her out.
I believe it is an isotope, but my reasoning is because an isotope is anything that is not what's the norm on the periodic table. So if it derives from what is shown normally on the periodic table, it's an isotope. So if it has less neutrons, more neutrons, or less electrons or more, is what I think.
You're closer, Christian. That was way closer than Kennedy, but still wrong. Okay, so to go off your thought, you said, oh wait, I have a chat. You guys just talk. I can't. Can you hear me? No, Camille, I can't hear you. You talk, Camille. Go ahead. Try talking. Oh yeah, no, sorry. Your microphone is jacked. Sorry. We're gonna keep going. But anyway, you're close, Christian. What you said is if something is different. Oh Lord, have mercy, Camille. Okay, sounds good. See you later. Okay. What you said was if anything is different from the periodic table, which is sort of correct, right? My whole thing that I just finished spieling about was if it's not the same, and here's hydrogen, if it's not the same isotope, it's going to have a different mass. That's exactly what I said. So that's why you said that, which is on the right track. What can someone tell me though, what the definition of an isotope? Because if someone can tell me, then we've got this down packed. It's not something that doesn't have neutrons. That's not it. And it's very simple. What is the definition of an isotope? I just said it spent like 3 minutes on it.
An isotope depends on the number of neutrons in the nucleus because the number of protons can never change.
Okay, but an isotope of hydrogen, for example, this is the most stable hydrogen, right? This one that's on the periodic table is the most common one, right? So this hydrogen has how many neutrons? And maybe Kennedy, this is why you said it. But this hydrogen right here has how many neutrons?
0.
Correct. So this particular isotope of hydrogen, which is the most stable isotope of hydrogen, has 0 neutrons. The definition of an isotope is the same atom with different number of neutrons. That is what the definition is. Same atom, different number of neutrons. Okay, so that's the most stable one. Hydrogen has, the most stable isotope has 0 neutrons. Okay. Does it have anything to do with electrons? Does the definition of isotope have anything to do with electrons?
No.
No, it doesn't. It only has to do with neutrons. Okay, so again, let's look at this third box. How many protons does this hydrogen have?
1.
1.
How many neutrons does this hydrogen in the third box have?
0.
So is it the same isotope as the first box?
Well, technically, yes, but technically speaking, it's...
Stop right there. Stop right there. I don't want any other information. Is it technically the same isotope as the first box? Yes, right?
Yes.
Absolutely. So if that's the case, if we understand that, because that's the only thing that isotope refers to is number of neutrons. So then my original question was, is this an isotope? Is this box an isotope of hydrogen?
No.
No, it's not. It is not, because again, it has the same number of neutrons as the first box, which is the most common one. Okay, so what is different then? Because there's obviously something different about this box.
It has a negative charge.
Correct. What gives you negative charges in an atom?
Gaining electrons.
Exactly. So how many electrons does a normal hydrogen have?
1.
Right. So how many electrons do you think this guy has?
2.
Exactly, which is why you have these 2 little black dots right here. So it's very important that you understand the difference between all of these 3 things and be able to recognize a symbol, right? So the symbols mean something. I'm not going to be writing out and explaining to you all the symbols, right? I'm going to show you a symbol and you're going to have to know what that symbol means. So let's practice that a little bit because we're just going to go over that over and over again. So if I give you, we're going to go back out to this side. I'm going to erase all this crap. Okay. If I give you this guy, who is that guy?
That is fluoride.
Okay, it's not fluoride. That is an, hold on, let me make this a little bit bigger. Does that look like an N to, a D to you?
Sorry about that. No, it's fluorine.
Okay, it's a fluorine. Yes, so that is fluorine. Good job. All right, how many protons does fluorine have?
9.
How many electrons does fluorine have?
9.
How many neutrons does fluorine have?
10.
Okay. How did you get that, by the way, for people that maybe aren't getting it yet?
Oh, because the atomic mass is 19. 19 minus the 9 protons leaves you with 10 neutrons.
Exactly. So what if now I say this, I show you that. So F minus 1. How many protons does that fluorine that I've drawn have?
9.
That never changes. Dumb question. How many neutrons does that fluorine that I've drawn have?
Still 10.
10.
Still 10. How many electrons does this thing have?
10.
And
Okay. I can hear you, Camille. Yes.
thank you.
All right. So it has 10. Why? Because again, it started with 9, and now it's telling you this atom has a negative charge, an overall negative, right? So it's unbalanced now because everybody on the periodic table is neutral. So if it has a charge and something is unbalanced, that means it has one more negative than it's supposed to have. So therefore, it's called an anion, right? So an anion of fluorine has F minus 1. Do you get that? Does everyone get that?
Yes.
Okay, so then how about somebody else that hasn't spoken, that maybe is unsure? Try this one. Who is this guy?
Magnesium.
Is that you, Camille? Okay.
Yes, I was just testing. I'm sorry.
Yeah, no, you're fine. Okay, so that guy right there. How many protons does that magnesium have?
2.
It has 2. Who said that? Who said that? You better you better put your camera on. Who said that? Sorry? Kezia. You said 2. It has 2 protons?
Wait.
Yeah, wait, I'll wait. What? Okay, first of all, that number there.
It has 12.
Okay. Don't make me upset because I just spent half an hour telling you that the protons are in the freaking box, yeah? All right, so that never changes. So it has 12. Okay, good job. It has 12. How many electrons does this magnesium have that I've just drawn? And think before you speak.
10.
Okay, good job. Camille, it was Kezia's turn.
Oh, I thought okay. I'm sorry.
Okay, but Kezia, did you understand why it's 10?
Yeah.
You sure? Okay, well then I'm gonna ask you another one. How about that? Okay, so then who's this? That's RB, by the way. I can't write. RB. Do you know
Rubidium.
Rubidium, good job. So how many protons does rubidium have?
37.
Good job. How many electrons does that rubidium have?
37.
Okay, yeah, it's not a question. It's not a trick question, right? So if it has 37 pluses, then it must have 37 negatives because they're all neutral on the periodic table. All right, how many neutrons does rubidium have? Just tell me how you would get the answer. You don't have to give me the answer. How would you get the answer?
I would minus 37 by the atomic mass.
Okay, so 85 minus 37.
Mm-hmm.
Okay, that's how you get the number of neutrons. Correct. Okay, so this. Now I'm changing the rubidium now. How many protons does that rubidium have that I've drawn?
38? 37? 37.
Is that your final answer?
No.
Okay, for you to be, you have to be confident, right? Like you've got to have conviction in here. Don't go with your gut. This is not hard. This is not a trick. So protons are never change. Kezia, ever. They don't change. It's your social security number. Does that change?
No,
No, it
no.
doesn't. So protons never change. So how many protons does rubidium have?
37.
That's it. Full stop. Great. How many electrons does this rubidium have?
36.
Why 36?
Because you have one positive charge, I guess, on it.
Okay, so one positive charge is telling you that there's one less negative, right? And I know it's like, oh, she says the same thing, but the currency, right? Like the money in chemistry are electrons. So you have to talk in terms of electrons. So yes, it's because it has one positive charge, but it has one positive charge because it has one less electron. Does that make sense?
Yes.
Okay, good job. Good job. And I think that is it for that. So does anyone have any questions before I move on? Any questions whatsoever?
I'm good.
Okay, so let's go back to this whole most common isotope, right? So the most common isotope is the dude that you see on the periodic table. So that kind of tells you that there's a different number of isotopes. There could be however many different isotopes of this one person. How do you know which one's the most common? The one that's on there, the one that's on the periodic table. So for example, carbon, like I said before, has carbon 12 and carbon 13. There's actually another carbon, but that's radioactive and you don't need to know that. Okay, so this mass right here of carbon says 12.01. Okay, that's the mass. With that mass, you know how many neutrons there are, you know how many electrons because of the protons, you know all of that. Okay, let's say you didn't know how many isotopes there were, okay? But I told you there's carbon 12 and there's carbon 13. So here's the question, so listen carefully. Which isotope is the most abundant, is the most common in the world?
Carbon 12,
Why do you say carbon 12?
because it's on the periodic table.
Wait, I couldn't hear you. Say that again?
Because it's the one on the periodic table.
Okay, but you're absolutely right, but try to connect it to its mass. Try to make your answer and connect the answer to its mass. Do you understand what I mean?
Yeah, I'm just thinking about how to word it.
So there's two isotopes, right? And here's the question. I guess here's a better question. How do you know which isotope has more percentage? Like if I remember, I told you if I went outside and I looked for carbon and I went back into the lab and I checked it, I analyzed it, I had 99%, you know, how do you know that it's not 50% and 50%? How do you know that? Is there a way to know that? Just by looking at the mass.
It's closer to 12 than it is to 13.
Boosh. That's exactly what I wanted to hear. That is exactly what I wanted to hear. That is yet another piece of information that you kind of subliminally know just by understanding the periodic table. If I tell you that there's two isotopes, you don't have to know the isotopes. So I say, okay, so the carbon has two isotopes and it's carbon 12 or carbon 13. You can automatically know, well, I know that carbon 12 is way more abundant because the mass is way closer to 12 than it is to 13. And if you look, oh my goodness, what did I just do? So if you look at other examples, I think in the quick tutorial, I used nitrogen. There's nitrogen 14 and there's nitrogen 15, right? So you know that nitrogen 14, right? So nitrogen 14 and nitrogen 15 cannot be a 50-50. It can't be. Because look at the mass. The mass is not 14.5. It's not half, right? It's 14.01, which means that it's way closer to 14. So there must be more nitrogen 14s in the world naturally available than there are nitrogen 15s. And actually for carbon and for nitrogen as well, is like I said before, it's 99% and 1% the other one, which is, I mean, it's a weighted average. Okay. And when I say weighted, it's this weight, not waiting in line. Right. So a weighted, oh, I didn't spell that right. Oops, my bad. HTED, a weighted average, right? So that means that every mass has a certain weight to it, and that's what determines the percentages of these isotopes. Okay, so nitrogen is very similar as far as isotope abundance, is very similar to carbon. It's got 99% nitrogen 14 and about 1% nitrogen 15, right? So does everyone understand that? You sure?
Yes.
Okay. So then I want to do, let's do some problems then. Or let's do some examples here. So this is what I was kind of talking about, hydrogen, right? So hydrogen, this is a symbol, a typical symbol that you would see for hydrogen. And this number up here, obviously, this is the mass number, right? So it tells you how much the mass, how much it weighs. What does, and I know the answer is here, but the number at the bottom tells you the atomic number. This is a typical way to show a symbol of an atom. And now you know that if anything is on the right-hand side, that'll tell you if it's an ion, if it has a charge, more or less electrons. Okay. So, like I said, there's three isotopes of hydrogen, but if you notice, they all have one proton because protons don't change. So obviously what's changing here, if you look at the top, is the mass, which means that the number of neutrons are changing. These are very, very common, which is why they have their own little slide. But hydrogen is used a lot in analytical chemistry because of this deuterium and tritium. They have characteristics that are very, very similar to the regular hydrogen. So they can do a bunch of the same experiments and you can know where it goes because it's different. It weighs a little bit differently, so you can tell. So this is really, really important. But anyway, it has, hydrogen is special. So these hydrogen isotopes have their own names. No isotopes other than hydrogen have their own names. But that P, that's what the P stands for: protium, deuterium, and tritium. Do you need to know that? No. But that's what those letters mean. So you don't really need to know that. Okay, so let's look at the bottom one. Who is that guy? Does anybody know who that guy is?
Uranium.
Uranium, yeah. It's very, very dangerous element. So can you tell me which one of these two is the isotope? Well, they're both isotopes, but which one is the uncommon isotope of uranium? By the way, if you don't have a periodic table, you need to have one. This is your warning. You need to have one on with you to class from now on, because we're going to keep referring to the periodic table. So if you don't have one, I will put it on the board. There you go. So it was just to show you, hold on. It was 235 uranium and 238 uranium. Which one is the least common one? Which symbol?
First the 235. 235.
Okay, so you found it. Uranium's down here. It weighs a lot. So you can go by weight, yeah? So it weighs a lot. It's 238. This one's on the periodic table, so that tells you that's the most common one. So that's right. The 235 is the one that's a little different. How many neutrons does this guy have? You don't have to tell me the answer. Just tell me how you would get it.
All right, so you will get it by subtracting 235 by the atomic mass.
Which is what? No, wait. No, that's wrong. What you said was wrong. You said 235 and you subtracted from the atomic mass. That's wrong. That is 235 is the atomic mass.
I mean, yeah, I mean 92 subtracted 92? By 92 is the number of protons, which is the ranking on the element table.
Which is the atomic number.
Atomic number.
That's what you were searching for. So yes, 235 minus 92. Why 92? Because 92 is the atomic number, which is the number of protons. Perfect. How many electrons does that uranium-235 have?
It has 92.
All right. Pretty simple. All right, so I want to do this problem here, this problem at the bottom. Before you guys speak, I want you to think, okay? Which of the following symbols gives you more information? Those two oxygens? Which one gives you more information?
The O17,
Why the O17?
because it gives you the amount of protons and neutrons, because it's the mass number.
And you actually, you know the number of protons, even though that the 8 isn't there, right? Because you know the symbol. And if you know the symbol, you can look at the periodic table, and that tells you the number of protons. But this guy here, right, this guy here actually gives you also a separate piece of information. Like you said, it tells you the mass. So this is a different oxygen than the typical oxygen that's on the periodic table. So it's an isotope of the natural isotope, of the most stable isotope. There you go. So does that make sense? For the people that don't talk, I mean, there's 17 of you here, and I hear the same people over and over again. Yes, hello? Love it. Can't wait till you guys take my exam. You're gonna be all shocked. Okay. Can't wait. Okay, so let's try let's do, yeah, it's almost time to go, but I want to do one more. How about we say this is rarely, you never see this, but who is this guy, and how many, tell me how many protons, who it is, how many protons, electrons, and neutrons it has.
Sulfur.
Okay.
It has 16 protons, 16 electrons, and 16 neutrons.
That's wrong. You had everything right but one thing, which is the same thing you got wrong the last time, Kezia.
It's 14, isn't it, for the electrons?
Oh!
Yes, it is 14 for the electrons. So if you know you get that in trouble, Kezia, you better start practicing that, because that's what you naturally want to go to. So you have to practice that, because that's like, this is super, super easy. So right, everything you said was correct, minus the electrons. It has 14 electrons because it has a +2 charge. Okay, one more. I know it's 4:30, but let's try tell me how many, who that is. Tell me who that is, how many protons, electrons, and neutrons this guy has. Somebody. If not, I'm gonna pick on you. Okay, let me pick on you. Can't wait. Genesis.
Yes.
Okay, how is this person?
Can you zoom in on the, wait, okay. Can you zoom in on the periodic table, please?
I did.
One more time. I got bad eyesight. Tellurium?
It's tellurium.
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 16 electrons.
Whoa, stop. How many, tell me the number, it's tellurium. Tell me the number of protons. Tell me the number of protons first.
Oh, 52.
Okay. And then let me just move this up so you can see the thing. So it's got 52 protons. Tell me the number, tell me the rest, the electrons and the neutrons.
75. No, I can't. Hold up. Okay. Okay. Yeah. So
you don't have to give me the answer. You just tell me how you would get the answer. So how are you trying to figure out neutrons? Is that what you're trying to do?
Yeah.
Okay. So how would you get the number of neutrons?
Subtracting 52 from 127.
That's incorrect. That's incorrect because I wrote, remember, look at the right? I wrote this is the symbol. So you wouldn't do 127.
I'm not looking at the periodic table anymore. I'm looking at 129.
Exactly, because that's the symbol I wrote.
From 129.
So 129 minus
52 is 77.
Okay, that's fine, perfect. But that's how you would do it. 129 minus 52. Good job. What about the number of electrons?
It should be the number at the top of the periodic table. Am I wrong?
That's wrong. That is absolutely wrong. So this whole entire class, I've said that the protons, right? Like the 52, that's the number of protons. That never changes. But everything else can change, obviously. The neutrons can change and the electrons can change. So if it has a charge, if my symbol here has a charge, then it's telling you something is changing. And that's telling you it's changing the number of electrons. So what does a normal tellurium have? A normal, forget this symbol that I've written. Just look at the periodic table. If it has 52 protons, how many does a normal tellurium have as far as electrons? Hello, Genesis. Okay. Does anybody else want to say what it is?
A normal tellurium?
Yeah, what is the normal?
52 electrons.
Okay, so what is the tellurium that I had? It had a -2 charge.
54.
Okay, good job. So she left. She left. That's ridiculous. Okay. Chemistry is starting. So you guys really need to get this down because it's only going to get faster and more hard than today. Today was really, really easy. On Wednesday, we're going to do a POGO and we're going to obviously do a bunch of this stuff. I mean, I showed you the first page of the POGO. So it's going to be just a bunch of easy questions. We're going to do that all Wednesday and probably most of Thursday, but then we're going to start going into the periodic table and the organization of it and kind of asking like the question, you know how I wrote those charges, O2 minus or S2 minus, like how the hell do I know that those are the charges that it makes? Or can it make any charge that it wants? No, the answer to that is it doesn't make any charge that it wants. It makes a particular charge. And how do I know that? That's what we're going to learn, I guess, on Thursday, at the end of Thursday. What else? The biggest thing about chapter 2 is nomenclature. That's towards the end of the chapter. But I really, really suggest that you start looking and start practicing nomenclature, the naming, how to name things. Because I am not going to give you, I'm going to give you words. I'm going to give you lithium fluoride, and you need to know what that is and how to put it in a formula, which is a lot of work from today. So, and when is our exam? Our exam is next Friday, FYI. All right. So anyway, any questions? If not, I'll let you go because it's already 5 minutes after.
I have a quick question. So, I don't think I'm in my group's Microsoft thing because they told me that to access it, I have to go on my Tuskegee email and go to Microsoft Teams or whatever. And I signed in with my Tuskegee email, but it's showing me a blank page. It's showing me that I have to use a code to access a team or a group.
So I will check. Can you stay on the line and everyone else can go? I'll check for Christian. Anyway, if that's it, thank you guys. Yes, Genesis, I see you're still there. I don't see you on my screen. But okay. Anyway. See you guys. Thank you. See you on Wednesday.
Thank you.
All righty.